Introducing AuditOne's Smart Contract Security Analysis for IOTA Heroes. IOTA Heroes is a GameFi project that has been in development since December 2021. Their goal is to create a strategy game in the adventure genre where players manage their NFT heroes by training them and sending them off on adventures. If successful, the heroes will receive tokenized loot. The project features an NFT Marketplace and a trading post that facilitate trades across both Shimmer tokens, Gold, the ERC20 game token, and game items. Gracious Ak1 and Zuhaib Mode, who are auditors at AuditOne, successfully audited the smart contracts of IOTA Heroes. The audit has been performed in spring 2023 using manual analysis. This report presents the findings regarding the audit performed on the customer's smart contracts. The audit results are as follows. Code quality scored at 95, indicating high standards of coding proficiency. Documentation quality achieved a score of 98, reflecting comprehensive and clear documentation. Security score attained a perfect score of 100.0, evidencing exceptional security measures. The following findings were reported to the client. Set trade offer and cancel trade offer functions does not use re-entrancy guard. To prevent this type of attack, it is important to use the re-entrancy guard or other similar methods to ensure that the functions are executed automatically and not re-entered until the previous invocation has completed. Contract funds can be drained out. Our recommendations will be the following. Add non-re-entrancy guard. Make the state changes before making the external call. Make buy offer and withdraw buy offer can be used to brick the accept buy offer. Have some time delay to call the withdraw buy offer once the make buy offer is called and place the active buy offers. Make buy offer can be used to place the active buy offers with 0 MSG.value. Check MSG.value is 0 when calling the make buy offer. Re-entrancy exploit in initiate adventure function. One possible solution is to use the checks effects interactions pattern. This means that the contract should first check if the calling conditions are met, then perform all internal state changes and finally interact with other contracts. By following this pattern, it becomes more difficult for an attacker to exploit the contract's logic. Specifically in this case, the developer should ensure that the ether transfer to the contract owner happens after the _initiate adventure function is called, rather than before. This can be achieved by using a withdrawal pattern where the contract owner can withdraw the funds after the adventure is completed and the payout function has been called. It is also recommended to use the re-entrancy guard library from OpenZeppelin. Calling Mint Founder Hero may accidentally lock user funds. There are currently two ways to fix this. Update the condition as you see on your screen now. Add a condition to check if some extra ether was sent and allow the user to access it. Using weak source of randomness via block timestamp for generating the affinity. Using external sources of randomness via oracles like Chainlink VRF. Use of low-level calls. To mitigate this issue, it's generally recommended to avoid using the call function wherever possible, and to use higher-level functions like send or transfer instead. These higher-level functions provide more safety guarantees, and are less prone to errors and vulnerabilities. It is also important to validate the _fee receiver addresses before sending ether. Incorrect value is emitted during fulfill trade offer for trade, ask value and for trade, offer value when there are fee is deducted. Use the correct ask value and offer value if there are any fee is deducted. Purchase takes more than what is needed. Consider the price value for further calculations at the line you see on the screen. Missing input validation for various functions. It would be a good practice to add input validation to ensure that the inputted address is not a 0 malicious address. This can be done by adding a required statement at the beginning of each function to check whether the inputted address is valid. Lack of re-entrancy guard for _mint hero, add non-re-entrancy protection in the places you currently see. Lack of implementation to remove the whitelisted address. If the address turns into malicious or compromised, admin cannot control it. In shop.sol, mapping uint256 = mapping address = bool. Store id_towser in whitelist is used to store the whitelisted address for each store ID. The whitelisting process is done by only store managers with help of the function you currently can see on the screen. Later, this whitelisted addresses are allowed to interact with function buy product to buy the product even if the shop is closed. Royalties are hard-coded. Add a function to update the percentage of fee collected protected. Missing or insufficient NatSpec comments. Consider including NatSpec comments in the contract code. Unnecessary gas consumption. Change the code. Malicious minter can mint tokens to zero address. Add a zero address check require. Account equals sign address 0. Cannot mint to zero address. Missing return value check for transfer from. Check for Boolean return value of transfer from. AuditOne's detailed review confirms that the IOTA Heroes smart contracts are well protected and efficient, reducing the risk of vulnerabilities. The IOTA Heroes team has effectively resolved all issues identified by AuditOne, ensuring their smart contract code is now 100% reliable. For the full report and more details on our findings, visit our website. Click the link below for more details. AuditOne, your trusted partner in blockchain security.